Well, hey, we're going to start a new unit on trigonometry. So the big question we're going to answer today is, what is trigonometry? And also we're going to say, how can we use these ratios to find missing sides of right triangles? To get us started, please do the do now. They involve right triangles and missing sides, and then we'll get started. All right, so in the first one, we have a right triangle here, 3 squared plus b squared is equal to 5 squared. And then we have 9 plus b squared is equal to 25. So that makes b squared equal to 16. Now b is going to be plus or minus 4, but because we are limited to only positive values, this is going to be 4. So we just found the length of this side right here to be 4. Obviously, it wouldn't be negative 4. So if the whole thing is 6 and this piece is 4, that leaves this to be 2. So what happens is, when you have a straight line in geometry, if this is a 90-degree angle, then this is also a 90-degree angle. So here we have another right triangle. So we're going to apply Pythagorean theorem again. So that's going to be 2 squared plus 3 squared is equal to x squared. And we're going to get 4 plus 9 is equal to x squared. 9 plus 4 is 13. And so that makes x equal to the square root of 13. So the square root of 13 is the length of x in the first one. Moving on to the next one, apply Pythagorean theorem here. We have a squared plus b squared. The other side to this triangle is x minus 4. And then equals c squared, which is going to be x squared. And what's going to happen is we're going to have to double distribute. I'm just going to speed this up. This is going to be x squared minus 4x plus 4. This one's going to be x squared minus 8x plus 16. And this is going to be x squared here. So then if we keep combining like terms, this is going to be 2x squared minus 12x plus 20 equals x squared. And if I subtract x squared over, I get x squared minus 12x plus 20 is equal to 0. Now that factors very nicely using the AM method of factoring. This is a quadratic. So we're going to get x minus 10, x minus 2. That gives us two answers of x equals 10 and x equals 2. Now think about this. Can x be equal to 2? The answer is no. If x is 2, then that's going to give us lengths that are negative or even 0. So that doesn't make sense. So x is equal to 10. So that would make this side 10, this side 8, and this side 6. And so our perimeter is 10 plus 8 plus 6. So perimeter is 24. Let's get into trigonometry. Let's read this together. Trigonometry is the branch of mathematics dealing with the relations to the sides and angles of triangles. So think of trigonometry as the study of triangles with the relevant functions of any angles. We have what's called a reference angle. That's an angle that we are going to refer to, and we know it as a Greek symbol called theta. In a right triangle, theta is never the right angle. So down here, angle C, that is not going to be theta. Theta represents an unknown angle, and C we know is 90 degrees. The three sides of the right triangle are the hypotenuse, which is opposite the right angle. I use an angle symbol for angle. The leg next to the reference angle is called adjacent, next to. And opposite, well, you guessed it, it is opposite. So we are going to just show you real quick what that means, and it's opposite that reference angle as well. So let's look at the first one here. If C is our reference angle, then this across from the right angle is our hypotenuse. The leg that's next to angle C is our adjacent. And the angle that is across from our reference angle is our opposite. Go ahead and pause the video and see if you can do it on the other shape. Now our reference angle in the other shape is going to be a little different. It's going to be up here at B. All right, so here is the hypotenuse is going to be right here, across from the right angle. Now, opposite the angle, the reference angle, and then adjacent to is the one next to it. And that's an important skill to have in trigonometry, is being able to identify the adjacent side, the hypotenuse side, and the opposite side. You might say, well, why is that important? The answer is because a trig ratio shows a relationship between two sides of a right triangle and a related angle. And an easy way to remember this is SOHCAHTOA. All right, SOHCAHTOA, very common little way to remember this. Here's how it goes. A ratio, remember, is just a fraction or a comparison of two numbers, right? So the sine ratio, we would say that the sine of x being our angle, is equal to the opposite side divided by the hypotenuse. The cosine fraction, or the cosine ratio, is cos x is equal to the adjacent side, the next two side, divided by the hypotenuse. And the tangent ratio is tan x equals the opposite side divided by the adjacent side. So what we're going to do is the next exercise before we start problem solving is, can you take this right triangle ABC, A being the right angle, and can you fill in all the trig ratios? So what would the sine of B be? The sine of B, well, if we look at B, is right here. So the opposite side is going to be 6, and the hypotenuse is 10. Now let's think about the cosine of B. Well, when we're talking about B, this is opposite, and this is adjacent. So the cosine is adjacent, which is 8, divided by the hypotenuse, which is 10. And the tangent of B, the fraction that represents the tan of B, is the opposite side, which is 6, divided by the adjacent side, A, which is 8. SOHCAHTOA. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now let's change our reference angle. So let me change colors here for you. And now C is our reference angle. Go ahead and pause the video and see if you can figure out the sine of C, the cos of C, and the tangent of C. So the sine of C is the opposite over the hypotenuse. The opposite over the hypotenuse is going to be 8/10. The cosine of C is the adjacent over the hypotenuse, which is 6/10. And the tangent of C is the opposite over the adjacent, which is 8/6. All right, let's quickly solve a few problems. Which equation shows a correct trig ratio for angle A? So they're telling you angle A is your reference angle. So this is the angle that we want to base our answers off of. Okay, so let's think about this. The sine of A would be the opposite, which is here, divided by the hypotenuse, which is here. So that should be 8/17. But this says the sine of A is 15/17. That is not true. The tangent of A should be, now again, write your acronym here, SOHCAHTOA. The tangent of A is opposite over adjacent. Now the adjacent to A is here. So that should be 8/15, not 8/17. The cosine of A is the adjacent over the hypotenuse. So that should be 15/17. That looks pretty good. Now the last one, just double check. The tangent of A is not 15/8. It should be 8/15, so that is no good either, leaving our only logical answer to be choice C. Moving on to the next one. The next one has us draw our own picture. So we have a triangle ABC, right? So just put the right angle in anywhere. And we know that angle C is the 90-degree angle, so A and B could be the other two. It is arbitrary. It does not matter. So AB is 5, and AC is 4. Now, I'm going to let you know right now, you should get very used to, for geometry, your most famous Pythagorean triple is 3, 4, 5. We call it a Pythagorean triple because it's a squared plus b squared equals c squared. And what happens is you get 9 plus 16 equals 25, and 25 equals 25. So we know that 3, 4, 5 is a very, very famous Pythagorean triple. So without much work, we know that the missing side has to be 3. So now let's think about these. We have the cosine of A is 4/5. Well, that means that A is going to be our reference angle for this question. So I want you to focus in on angle A. Now the cosine would be adjacent over hypotenuse, which is 4/5. Well, that's true, but this says which is not true. So that is not our answer because that is true. The tangent of A, so katoa, is opposite over adjacent 3/4. So that's correct. Now let's change our reference angle. Now we're going to zone in on angle B as our reference angle. So the sine of B is opposite over hypotenuse, which is 4/5. So that's correct. So this has to be the answer here, but let's just double check why. The tangent of B should be 4/3, opposite over adjacent, but it says that it's 5/3, so that is not true. All right, so one of the main skills we're going to work on today is finding the missing side of a right triangle. So here, let me teach you real quick how we're going to do this. So we have this angle here, 38. That's our reference angle, okay? Now I need to figure out this side x. So what I'm going to do is I'm going to figure out a trig ratio. So if I write SOHCAHTOA, just to help me, what that helps me do is says, okay, x is opposite 38 and 21 is adjacent. So which trig ratio uses opposite and adjacent? Well, that's going to be our tangent function. So tangent of our angle, so the tangent of 38 degrees, that's our angle, is equal to a ratio that is opposite, which is x, divided by 21, which is adjacent. Now what you'll notice is this really is just a proportion. So we're going to cross multiply. So I'm going to multiply 21 by tangent of 38. And I'm going to set that equal to x times 1, which is x. Now here's where we need to get our calculator out. Now there's something that's really, really important that you need to make sure before we begin. If you go into your calculator, there is a mode button. You need to click on the button that says mode, and you need to make sure that your calculator is in degrees. Now, your calculator has two modes when it comes to measuring angles. The two modes are degrees and radians. So you need to make sure that your calculator is set for degrees. So what you need to plug in your calculator is 21, tan, there's a tan button, and then 38, and you're going to hit enter, and your calculator is going to give you a solution, 16.4 to the nearest tenth. All right, moving on to the next one, find the perimeter of the right triangle. So first let's solve for x here. So if I solve for x, I need to know what trig ratio. So I'm going to reference this angle 30. So I know the opposite side is 24 and the hypotenuse is x. So that's a sine function. So the sine of 30 is equal to the opposite over the hypotenuse. Now again, this is a proportion. So I'm going to cross multiply. That's going to give me x times the sine of 30 is equal to 24 times 1. Now how would I solve for x? I would divide out the sine 30 on both sides. So that gives me that the x is equal to 24 divided by the sine of 30. So get out your calculator and do 24 divided by sine 30, and it should give you a value of 48. So what does that tell me is that my missing side, x, is 48. Now you might say, should I use trigonometry to find y? The answer is, if you want, you can, but when we know two sides of a right triangle, we can always find the third by using Pythagorean theorem. So that's what I'm going to do here. So y squared plus 24 squared is equal to 48 squared. A squared plus b squared equals c squared. And if we simplify this, we get y squared equals
1,728.
And that gives us a value of y of approximately 41.6. So, in order to find the perimeter, I need to add up all three sides. So the addition of 41.6, which is this side, 48, which is this side, and 24, which we have, is going to give us a perimeter of 113.6.